Hello, it's Mr. Clark here, and I thought I would do some teaching for a change. So I'm going to talk you through KC calculations. That's probably a little bit tricky to teach yourself. So I'm going to have a look at question 3 from your problem sheet, which is available for you to do. And it is as follows. So 1 mole of nitrogen and 3 moles of hydrogen are left to reach equilibrium in a 2 decimeter cubed vessel. So those two things are mixed together and equilibrium is established, and the equilibrium mixture contains 0.5 moles of ammonia. Calculate Kc. So the first thing you need to do is work out the equilibrium amounts of these three chemicals in the Haber process. I'm going to talk you through the ICE method. So that is the initial, the change, and the equilibrium. So to begin with, you have 1 mole of nitrogen and 3 moles of hydrogen and no ammonia. And it says that the equilibrium mixture contains half a mole of ammonia. So that has gone up by 0.5. Because of the mole ratios 1 to 3 to 2, the stoichiometry, ammonia has gone up by 0.5, but that's worth 2 equivalents. So that means 1 equivalent is 0.25. So where the products have gone up, the reactants will have gone down by 0.25, and here for hydrogen, 3 lots of that is down by 0.75. So the equilibrium amounts of all of these chemicals is 0.75 for nitrogen, 2.25 for hydrogen, and 0.5 for ammonia. So then we can calculate the concentrations of these by doing moles equals concentration times volume. It is all in a 2 decimeter cubed vessel. So what we do is we take 0.75 divided by 2, which is 0.375 mole per dm cubed. For hydrogen it is 2.25 over 2, which is 1.125 mole per dm cubed. And for ammonia it is 0.5 over 2, which is 0.25 mole per dm cubed. So the next thing to do is have a look at the equilibrium expression. You should be familiar with this from AS level, and what you can do is you do the products over reactants. So in this case it's the concentration of ammonia, and that's to the power of 2, because it all depends on the ratio in the equation. So that's the power of 2, and that's over the concentration of nitrogen times by the concentration of hydrogen, and that is to the power of 3. So that is your equilibrium expression. The next thing you can do is plug in some numbers. So taking your concentrations from down here, you can do 0.25 squared over 0.375 times by 1.125 cubed, and that to 3 significant figures is 0.117. So the next thing to do is just to have a look at the units for Kc. So just to keep it simple, I always like to do my units as a separate little calculation. So let's just call mole per decimeter cubed m, and it will make it a little bit easier. So on the top we've got 2 lots of concentration, so let's do that, and on the bottom we've got 1, and then because that's to the power of 3 we've got 4 lots of concentration. And hopefully you can see over here that we can cancel out some, so it's a case of adding the powers. So we've got 1 over mole per dm minus 3 times mole per dm minus 3, which is 1 over mole squared dm to the minus 6, which is actually mole, if it's 1 over, it's mole to the minus 2 dm to the 6. Those are your units. Your answer is 0.117. So your final answer is Kc is 0.117 mole to the minus 2 dm to the 6. Hopefully that is a little bit easier to understand how to do those type of problems now that I have shown you. Stay safe, and if you've got any questions, do ask. Thanks. Cheers now.